Hello, welcome to another conversation between Matt and Bentley, and we are here to talk about something interesting and exciting that has to do with building power-ups today. I'm Bentley. I'm a developer advocate at Atlassian, and I'm joined with Matthew.
Hi, thanks for joining us again.
And we're going to talk about something today, storing secrets and what secrets are. And this is prompted a little bit by, there's been some conversation in the developer community recently in Trello about whether an API key is secret or not, and whether it should be publicly available or not. And I'm here to say an API key is okay to be shared publicly. It's intended to be seen by many, and that's fine. But there are cases and there are things that are not meant to be shared publicly, like your application secret, which you'll find further down below your API key on the /app key page. And more importantly, Trello tokens, which are generated from an API key when you're asking a user to authorize. And so we're going to dive in today to how to store a token from a user, not an API key, because API keys can be public, but how to safely and securely store a token from a user. And so let's jump in. Matt, tell us about t.storeSecret.
I think it's great that people are asking and making sure, right, that, is it okay for this thing to be public, right? Or versus is it not okay for this thing to be public? Because I think, right, the biggest trick with secrets is, right, knowing what needs to be kept secret and then doing the right thing, right? And keeping said secret thing secret. And there's a lot of steps that can go wrong at, right, where you can accidentally think
a lot of steps, yes.
Right, think that oh, this is totally secret, right? I don't check it into my code, but in the build process, it gets built into my client, and then I ship the client out to users, and it's maybe not secret anymore. I get it. Sure, GitHub doesn't know it, but everybody else that downloads your client does. So lots of opportunities to mess up and make something that should have been secret, like the application secret, not secret, and that's just a headache for everybody. So exactly as you said, let's talk a little bit about one way, and numerous ways, of keeping your secrets secret as far as they relate to your Trello Power-Up. So I think you mentioned something about storing secrets.
The naive Bentley is going to jam a token. So I'm going to ask the user to authorize my Power-Up because I need to do something like move cards around on the board. So I ask the user to generate the token, and I could, if I had my own, I could store it in my own database.
Yep.
Which seems like a lot of work because now I'm spinning up a database, and I don't really want to do that because I was just making a little Power-Up. Luckily, Power-Ups do give me the ability to call t.set to store data. So I could just call t.set and store the token.
Yep.
It feels a little bit bad because I know I probably shouldn't be just jamming a token that isn't encrypted, isn't, I haven't done anything with it. It feels bad to just jam that into t.set. And I could be a bad developer and accidentally put that in a scope other than private, which we've seen. So it's just a lot of opportunities to screw up along the way, and I will certainly screw up. So it seems like I should use the thing that's very aptly named about secrets.
Yeah, and I think you make a good point, right? Tokens, access tokens, right? Especially for other services, are one of those things where your users are trusting you a great deal to not screw them over, and when they give you that, they expect that you'll be very careful with it and keep it secret. In the case of Trello tokens and storing them in Trello, that's an interesting gray zone. It's not necessarily the end of the world to store Trello tokens in Trello's dedicated storage so long as you said, right, you're very careful that you're using the right scoping and making sure that the token that you're storing in Trello is scoped just to the member for whom it belongs. But certainly once you exit out of even that gray zone into okay, now I'm dealing with, say, a Bitbucket token or a GitHub token or something that's not Trello, right? It should feel a little bit awkward to you to store that inside of Trello, right? Because now you're storing, right, some other services tokens, and you're having kind of Trello be responsible for the kind of security of that. I get it. Like Trello will go to the extent that they will to keep that secure and secret, but like if there's an option to not even have to trust them to keep it secret, right, that seems even better. So as you've alluded to, I think today we're going to kind of get into a little bit about what Trello calls t.storeSecret. And again, as Bentley mentioned, this is very much for power-ups. So we'll just take a quick glance here at the documentation for this, right? Very much under managing secrets. And we've got three things that we can deal with here. Store a secret, so kind of key data. I like the kind of example here is very much what Bentley's getting at. Store a secret, our key we'll call it a token, and then the value, which in this case might be the actual access token value itself. When we need it later, we'll load it. And then if we're done with it and never need it again, we can call clear secret and get rid of it. So
very, very clean, very obvious. Set
right,
it, get it, and blow it out. Like if you can stop watching now and you've learned, like if all you care about is using the thing, then this is how you
copy paste the code, which is I think an important goal, right, of any author of documentation is if you're going to give somebody code, make it copy pasteable, because that's what everybody's going to do. So go ahead, copy paste the code, replace the values that you need to replace, and you're off to the races. But I think we'll take a few minutes now for those that are interested, right? And you're right. If that was all you needed, leave, go ahead, use it, you're good. But if you want to know how this works and like a little bit more about what is actually happening, why is this any more secure, then hang on with us, because we're going to talk a little bit more about the kind of underbelly of what it means to store a secret and encrypt and keep things secure. So let's switch to that. Talk to me. I'm going to switch back from my screen share here in a second, but what do you know about kind of web crypto, right? Or kind of this idea of crypto kind of in the browser?
Yeah,
if got pulled up here.
If you have enough browsers running, you can create cryptocurrencies.
Oh, this is a good idea. The classic insert a script into a website that then mines Bitcoin on your behalf.
No, crypto. I actually don't know a lot about crypto, but I do know that or I find it interesting, as we've talked about before, that when you're talking about cryptography, it feels a little bit wrong sometimes to be talking about crypto happening on a browser, because your basic crypto is you have a key that you're using to encrypt some data. It feels weird to make both of those available in the browser at the same time, but I understand that is part of what we're doing for t.storeSecret. Right.
And I mean, we won't get into this too much, but of course, right, there are various kinds of cryptography, right, like symmetric cryptography, asymmetric cryptography, right? Right. So like symmetric is it's the same key both ways, right? You use the same key to encrypt, decrypt. Asymmetric, right? Asymmetric, it's not symmetrical on both sides. So web crypto is, the browsers do a lot of cryptography already, right? Which is obviously, or perhaps this is obvious, right? Like when you connect to things over HTTPS, like the browser is having to do encryption, decryption. So browser vendors, right, have already built all of this cryptography in, right? And certainly one of the things that you hear most often said when anybody's talking about cryptography is do not roll your own, right? Like the classic mantra of don't even try. It's not worth trying. You're going to mess it up. So one of the nice things here is if you need to encrypt, to decrypt something kind of in the browser, the last thing you want to do is write your own, okay, let me go look up how you're supposed to encrypt something, write your own algorithm and hope for the best. You'll get it wrong in very interesting ways. So instead, right, the browser's already done this for you. And even more nicely, the browser has exposed to you as an API, hey, yeah, I already know how to do all these different cryptography things. Here's a whole library of them, right? The browser's hanging off of this window crypto object. And I mean, impressively to me, this goes back, even if you're still supporting IE11, this all still works, right? t.storeSecret works on IE11 and all the way up, which is kind of surprising and neat, and does a bunch more than just encryption, decryption. You can use it to get secure random values if you want a secure random number generator in your browser. You can use it for hashing, right? Which is, I guess, one-way cryptography, right? Where I want to take this value, turn it into something else in a way that you hopefully can never go back to the original value. So all of that's in there, right? So some of those things might be useful to you. Others right? Less so. Maybe you don't even need encryption. You just need hashing. Great, like that's already provided for you. Interestingly, and we won't go too deep into this, but maybe we'll post a link in the video description. A lot of this is exposed in an even friendlier way inside of Power-Up.js. I think it exposes a thing called simple crypto, which is in hindsight probably a bad naming of the file there. Is crypto really simple? Which kind of papers over some of the differences here between Windows 11 or IE 11 and different browsers, and lets you kind of do things like hashing and encryption separate from t.storeSecret, kind of on your own, but still in a kind of wrapped, slightly nicer way than interacting directly with window crypto. So again, we won't look at that, but we'll post a link so you can kind of take a look at those that file for yourself and see if there's anything in there that might be useful to you. So okay, so we've talked about, okay, this uses window crypto under the hood. There's a thing called t.storeSecret. It encrypts, but you mentioned, and maybe you should talk a smidge more, like, are you actually secure if you're encrypting in the client itself? Right.
Right.
Yeah. What do you mean by that?
Based on the documentation, is Trello will generate a new encryption key for the member if it doesn't have one, and then it'll use that key to encrypt the data that you want to be secret, and then it jams that key into your browser's local storage, which makes sense because you're not then storing, you're never putting that key, the encryption key, in a database. You're just putting it into the browser's local storage. So yeah.
What does that protect you from? So a couple scenarios I think that are worth thinking about. Let's start with the first one, right? Like the first one is separation of like who knows what. So in this case, right, compared to your first example of using t.set and just putting the token in Trello, in that case, both your Power-Up and Trello know the token, right? Trello has it because they store it, and your Power-Up has it because it can request it from Trello whenever it wants. So if either of those two properties are compromised, the token is compromised, right? So if somebody compromises your Power-Up, obviously they can get the token. If somebody compromises Trello, they can also get your token, right? So right now, if we did, as we said in the beginning, both are avenues of access to that thing. And what changes if you do t.storeSecret then in terms of compromise?
You have to have your browser effectively compromised. Your local storage has to be available to the person, to the attacker.
Right.
Because that's where your key is. So which right in the real world, like effectively means someone has to get on your computer and open up your browser.
Not quite right. Although that is actually, we're going to get to that because that is a different way that we're protecting users here.
Because can I guess?
Yeah.
Can we dig into this? Is it because we're storing? Can you store against a domain for local storage? So
yeah. So this is stored only on your Power-Up's domain in their local storage. That's right.
Right. So someone malicious actor on another website can't get to the local storage.
That's right. Yep.
Yeah.
However, I guess let's say if I have an XSS against your Power-Up, right? So I don't have physical access to your machine, but let's say there's a stored XSS. Will I be able to get that token?
Yes, because you're able to execute JavaScript on the domain.
On that domain, right? So even though it's encrypted in local storage, if you can run on that domain, you are the Power-Up, right? Therefore, you can request both the encryption key and the encrypted value, do the decryption, and you're off to the races. So certainly, if your Power-Up is compromised, all the information is still there. However, what we've taken away in this is now you don't have to trust Trello anymore, because if Trello is compromised, all they have is your encryption key, but they don't actually have the encrypted value to use it on, right? So we've taken away half of the surface area, which is a good start, right? Like part of security is reducing your attack surface area. So we've narrowed it down. We took out half of it, but you did make an excellent point, which is physical access to the machine, which I feel like often you kind of like just say, well, the user's screwed if somebody has physical access to their machine. But I do think there is one common scenario that maybe we don't spend too much time thinking about, which is like public machine, right? Like somebody goes to the library, right? Signs into Trello or whatever in the library, uses your thing, and they sign out of Trello, right? Because they're being good, right? Like they sign out of Trello, whatever, they leave. Now, unless like it's very likely that your payload, like again, if you just stored, so this is interesting, right? If you stored in t.set again, you're okay, right? If the user logs out of Trello, they're fine.
Right.
However, if you had just put it in your local storage, but unencrypted, right? You're not necessarily guaranteed to have had a chance to clear that local storage when the user logged out of Trello, right? Depending on how they logged out of Trello.
Right.
Therefore, that's still sitting there, right? So if somebody else comes onto that machine, opens the browser and starts looking through local storage,
they could see that token.
Right. I guess what's in theory sitting there, right?
The
token.
Yeah.
It's sitting there unencrypted, right? You can just read it. Now it's great. You have that person's token, right? Which is like, yeah, okay, nobody broke into your house and stole your laptop. You just happened to like, you signed in a public venue, and now it's kind of sitting there waiting for somebody to take a peek. So that's another thing that you're protecting kind of users from by choosing to encrypt it, where the encryption key is not stored in the same spot, right, as the thing you encrypted, because otherwise, I mean, you haven't achieved anything. You're storing the encryption key in one place, the encryption thing in another. That way, right, if you only get access to one, you don't have access to everything.
Right. It's like finding a house key out in the middle of a street as opposed to in front of the door.
Right.
You're like, okay,
now you need to go find the right house. Yeah.
I'm on Fifth Avenue, New York City. It's like, who knows which door this goes to?
Exactly.
Okay, so I kind of want to see it.
Yeah, let's do a quick demo.
Yeah, and we talked about using this as a teaching moment to show. One of the things I didn't realize when I first started playing around with power-ups, and in particular how we use iframes for power-ups, you can execute code on your power-ups iframe from most browser developer consoles. And so is that what we're looking at right now?
Yeah, I think that's what we're going to try here. So we've got Trello open to a board that's got a power up on it. So this one has our little weather power up. We have a whole series on building this power up. Click on the card in the top right of your YouTube window to see how that was made. But all right, so we've got this power up here. And so what we're going to do is this tends to be easiest if we have what we'll call a kind of secondary iframe, right? So this what we just opened here, right? This is if we look at this in the DOM, right? Well, this frame is kind of giving it away. But let's just inspect it here so that we can all agree that what this is a iframe. Of course, we're already in it. Okay, here we are. So beautiful. So great. Our power up has created an iframe, right? And your power up might be creating iframes in lots of different places. In this case, it's the show settings one, but maybe you have attachment sections, maybe you have modals, whatever, it doesn't matter. And if you're showing an iframe, this trick will be kind of nice and easy. So here we're using Firefox, but you could do the same in Chrome, perhaps even a little easier. You want to find the right frame. So luckily for us, I think Chrome does the same thing. As you hover over frames, it highlights which one. And so we know we're picking the right one.
Looking at this, our netlify.app,
yep,
that is actually our
connector
URL. Yeah, so we have multiple iframes from our power-up domain. Yeah.
Yeah, that's why I call this one the secondary, right? So I guess I'm thinking of your iframe connector as your primary one, and then any other ones that you kind of end up displaying as secondary ones. So I'm just going to select that so that we're in the console here. We are in the context of that frame. The reason that's important is on the window object, which again, if you've written a PowerUp, you're familiar with the fact that when you include PowerUp.js, it exposes the Trello PowerUp object on the window object for you. So we've got access to it here. And that's great because that's what we want to use. So I'm actually going to give ourselves a variable here. We'll do const Trello equals, and all we're going to do here is the same that you would have done in that secondary iframe, right? If we look at the code for this will have this line in there somewhere where we initialize the iframe. Great. So now we've got the same Trello object that we have in our code in there. So that's again, for if you're just playing around or trying to test something out, then great, right? You can do, this is going to give you all the set or get all of those functions are going to be here. So in this case, right, we're going to do store secret. I think there we go. It's even auto completing for us, which is lovely. And so we said this is going to take a key, some key. We can call that whatever we want, and then a value, right? So this will be our, it's a secret. All right. So what this is going to do asynchronous. This is well, this will return a promise. So to know when it's done, we'll have it tell us. Great. So I've stored the secret. So let's just take a quick peek at what that actually did. So we said in storage that we store in local storage. So great. Lovely. We've got this lovely encrypted, well, two things happened here. So here's the value is the encrypted value. The key is, we talked about how the crypto library can also do one-way hashes. So that's what's happened to even the key. We don't store that in plain text. There's no reason to in the event that you're using a key that might itself be sensitive. So the key is one-way hashed. That gets you a key here, and then the value has been symmetrically encrypted using a encryption key that was generated for you. But we don't see that here. So okay, so if we let's load that secret to make sure that that's all happy, right? So as long as I give it the same key, the beauty of the one-way hash, right, is same key is going to hash to the same thing. We could talk about salting and all those other things, but not relevant for this. So we're going to load this, and then we're going to say, okay, once you've loaded it, log it out, right? Again, this is a promise because under the hood, this is going to ask Trello for your encryption key. It's going to load the thing out of local storage, do the decryption, and then asynchronously, right, give you back the result. And look at that. It indeed has decrypted our value that we saw in local storage and give it back. Let's do one last thing, right? So if we know that we're done with that and that we don't need it anymore, again, we can give it that same key and say, hey, take care of this. So now if we pop back here, right, great. There's nothing in local storage. It's found the key, it's deleted it. We're all clean. Let's take one last peek here at the encryption key that we talked about. Oh, we should have that print out. And so here, okay, so we're here, we're asking Trello, hey, give us back any of the stuff that we've stored, because what's happened is t.storeSecret on your behalf has had to kind of create and store something on your Power-Up here. So what it does is it creates a CBC. So right there is the name of the encryption algorithm that Trello has chosen to use. Right, it's an AES encryption with CBC. I'd have to look up to remind myself what that acronym is for. I actually don't know off the top of my head. What CBC is, is it elliptic curve? Is it, who knows? Some fancy encryption algorithm. Importantly, that was one that was supported across all the browsers that we wanted to support, right? So this is how we get support for things like IE 11 and Safari 9. I don't remember how far back Safari goes. Right, so least common denominator there of encryption algorithms, but that's where we see the key. So this is the key that's going to be used to encrypt things. So that's kind of a little demo there. I think let's close this off just with some kind of final caveats around using this.
Secrets are dangerous. Be careful.
Right. Well, again, yeah. Obviously, think twice. Right. Anytime you're dealing with secrets, right? Think your way through. Like, okay, if I was trying to get this, like, what would it take, right, for me to get it, right? You want to be thinking about what is your surface area, right? Have I reduced the surface area as much as I could? Could I reduce it more, right? Like, that's the thing, right? Maybe you're storing it in Trello today, but in doing so, you've added Trello to your attack surface area. Like, you may or may not be comfortable with that, and you might choose to be able to reduce that surface area a bit, by switching to something like this, or other things, right? As Bentley alluded to in the beginning. It's another option, right? Is you could have your own database and you could have your own authentication and authorization mechanisms in order for your client to be able to access data, right? And then in which case you're protecting the data and access to it on your own and in your own systems. In closing, so we said this is stored in local storage. I think there are probably a couple caveats that go with that. Can you think of like one or two caveats to this thing living in local storage?
I cannot. I can think of other things that we probably want to know about, but not related to local storage. Yeah.
So I guess, well, let me start you with one. People can turn off local storage. So that's
right.
So you will have to do some error handling here, right? It's not necessarily guaranteed that the user, the browser that's being used has local storage even enabled, right? So that's kind of one thing that you have to take into account here. For this to work, the local storage needs to be enabled. What about if a user uses multiple machines or multiple browsers?
Then they'll have to do it for each one.
Right. Local storage is not synced, of course, between different browsers or different machines. And as such, right, if they use Firefox today and use Chrome tomorrow, your secret is not going to be there in Chrome, right?
Right. Or if you use Firefox today and Chrome today.
Yes. And Safari and Edge and Opera and Brave and if any of those want to sponsor the show.
The other thing that we were talking about is just general gotchas that we see with Power-Up submitted. And we've already been over one, but I'll say it again because we've seen it so many times. And that is storing a token or a secret of any sort via t.set in the public scope.
Right, shared, yeah.
Or shared, which means anyone with read access to the board can read that, which does mean that if it's a public board,
right, easily forgotten.
Anyone on the internet
can be public.
Yeah. And then the other one was that you brought up when we were talking the other day was shipping secrets as part of your source code or in general, right? It's bad practice. It's not bad practice is terrible, abhorrent, should never be done.
But happens all the time.
Secrets of any sort into version control, but in particular, shipping secrets as part of your static assets with, you put something on your iframe because you're going to need it, or a common one I think we see is if you're using your application secret because you're doing the OAuth flow, hard coding that into a client.
Exactly. That should only be used and stored server side. But yeah, it's such an easy mistake to think, right? Like people just forget. I think that anybody can, when they go to your website, they can look at all the source code that came along with your website. And sure, you might have minified it, but like that's not that itself does not protect it.
Yeah. Cool. What else? I feel secreted out. I have no more secrets to share, Matt.
My secrets.
Secrets.
Well, all of my secrets will remain secret because I'm careful about keeping my secrets secret. So I think with that, before we divulge accidentally any of our secrets,
we don't want to secrete any of our secrets.
Right. I think we should leave it there. Of course, right. Leave comments or otherwise reach out to the Trello team or Atlassian if you have. Right. Again, I think it's great that folks are asking questions about, hey, should the API key be secret, right? Because it means you're thinking about that you're thinking about it, and that the first step to not messing up with secrets is remembering that they're secret and keeping that in front of your mind as you do anything with them. Right.
All right. Until next time, your secrets are safe with me, Matt.
Your secrets have been leaked all over the internet.